What's up, everyone? This is LeetCode 238, product of array except self. So, given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. So, yeah, basically we have this input array nums, and basically for every given value in a specific index, we have to return the product of everything in the array except that specific um, index value. Okay, so here for this one, right, at index 0, we have to return the product of 2, 3, and 4, right, which is 24. So that goes here. For index 1, right, that's the product of 1, 3, and 4, which is obviously 12. That goes there, right? Here for this index, we have to return the product of 1, 2, and 4, which goes to 8, so that's there. And then here for this 4, right, the product of 1, 2, and 3 is 6. Okay, so what you'll notice is, right, when we're at a given index, right, basically everything to the left of that specific index and everything to the right, the multiplication of those two things gives us the value we need that we can replace for this index, right? So for example, if we're at this 2, right, we take 1, because it's the only number to the left of this 2, so 1, and we multiply that by everything to the right of this 2, which would be 3 and 4, which is 12, right? Right? And of course, that gives us our answer when we multiply those two, which is 12. So a 12 should go here. Okay? Now, think about it like this in terms of how we're going to approach this problem, okay? Rather than doing that for every specific index, that operation for every specific index, we can just basically calculate everything to the left of every index, put that in an array, calculate everything to the right of a specific index, and then multiply those two. So basically, build out multiply everything to the left of this, right? Store that somewhere in an array. Multiply everything to the left of this, store that in an array. Multiply everything to the left of this, store that in an array. Multiply everything to the left of this, store that in an array. And then we're going to go backwards in the array. And we're going to do the same thing, but for everything on the right. So everything to the right of this, right? And then we're going to multiply this by whatever's here. Multiply everything to the right of this, and multiply that by whatever's here, etc. Okay, so this concept of like, okay, when we're at a given index, multiply everything to the left and to the right, and that should give us our answer. We're basically going to do that, except we're going to not do it for a specific index. We're just going to do it for the entire array all at once. From everything to the left of an index, then we're going to go back and do that for everything to the right of a specific index. Okay, that's how we're going to do this. Okay, so we're going to start at the beginning, and we're going to store that in a different array, obviously, because we don't want to replace any of these values when because when we go backwards, we need use these values, right? So we don't want to actually want to replace them or anything. Okay, so we're gonna go here, right, and we're gonna have something called a prefix, right, and that's gonna be set to 1. Okay, because we need the prefix, basically the cumulative product of everything to the left of whatever index that we're on. Okay, and initially it's going to be 1 because when we're starting here, for example, well, there's nothing to the left of this, but we don't want to multiply that by 0 because that would give us an incorrect answer. Okay, so we're going to set this to 1. Okay, and so what we're going to do is we're going to take, and by the way, this answer right here, technically, initially everything is not empty, but it's set to 1. Okay, and the length of this is just the length of nums. Okay, so basically we create this answer array by taking the length of nums, and we create the answer array from that, and populate everything in the answer array initially with just ones. Okay. And so the way we're going to do this is we're going to take, we're basically going to, at a specific index, right, for answer, right, we're going to take the prefix, right, and multiply that by the answer of I. Now, when we're doing this for the prefix, we're basically just multiplying prefix by 1 every time, right? So really, we're just replacing answer of I with prefix initially. But the reason I still write it like this is because we're gonna have to do the same thing with the postfix, and when we're going from right to left, these won't be 1 anymore. Okay, so I'll show you what I mean. So prefix initially is 1. Okay, and And after we do this, by the way, we have to update the prefix to equal the prefix times the nums. The nums. Okay. So let's start solving this problem. Okay. So we're gonna start at the beginning of nums array. So we're gonna handle this. Okay. So we need to take answer of I. We need to replace that by prefix times answer of I. Well, 1 times 1. So here we basically just replace that with a 1. The prefix would be 1 times nums of I, just 1. So again, prefix stays that. Okay, now we're here. Okay. Let me go to a different color actually. Now we're here. Okay, so we're going to do the answer of I be prefix times answer of I. So 1 times 1 is 1. Okay, it's fine. Prefix should be prefix times nums of I. So it'd be 1 times 2. So that would be 2. So prefix actually changes now. Okay. Okay, so now answer of I should be prefix times answer of I. So here should be just 1 times 2. So this actually becomes a 2. Okay. And prefix has to get updated by doing prefix times nums of I. So 3 times 2. So this should be a 6. So before I go any further, right, I need you to I'm trying to delete only this. Whatever. So we already did this. We did this. Did this. Now we're here. So before we go any further, I need you to understand that we're replacing answer of I, right? And then we're updating prefix by doing this times this. So why are we updating prefix? Because when we're here, before we replace anything, in the prior step, we updated prefix. So we're basically updating the multiplication of everything here. So that when we're updating this spot here, the prefix really is just everything here. The multiplication of everything to the left. Okay. So I need you to understand how these things connect. Okay. Now we're here. Okay, so we're gonna do prefix times answer of I, so 6 times 1. It's just 6. Okay. And then prefix has to get updated, so we're gonna do 6 times nums of I, so 4 times 6, which is 24. But this actually doesn't matter because there's nothing to the left of, or sorry, to the right of this. So this 24 is actually never gonna get used anyways. Okay. Okay, let me delete this. So we did all this. Okay. Now we handle basically the multiplication of everything to the left of each of these. And now we need to do the multiplication of everything to the right of these. So we're gonna go from right to left. Okay. So instead of using prefix now, we're gonna use postfix. Okay. We're gonna use a variable called postfix. And it's the same concept, okay? But we're starting from the right side and going to the left side. I'm just gonna call it PF, by the way, just so I don't have to spell it out. This up here should postfix, okay? The PF just means postfix. I just don't want to spell it out, okay? So now we handled basically for every spot, right? We handled what's the multiplication of everything to the left. And before we even do the postfix, let's just verify this, okay? Well, there's nothing to the left of this 1, so it should just be 1, because that's really, there's nothing here, right? But we don't want to multiply by 0, so we're multiplying by 1. Okay, everything to the left of this, right, should be just 1, right? So 1 goes there. Everything to the left of this 3 is 1 and 2, so it should be 2. Everything to the left of this 4 is 3, 2, 1, 6, okay? But we didn't handle everything to the right, so these aren't actually the right answers yet, okay? So now we're gonna do the postfix. Okay, and I'll just use orange. Or I don't know what this color. Is that red or pink? I can't even tell. I don't know what you would call that color. But anyways, so we're going to do the postfix now, okay? So postfix initially is 1 also, because there's nothing to the right of this 6, obviously, but we don't want to multiply by 0 because that would completely distort and give us the incorrect answer. Okay, so now we're going to do answer of I is postfix times answer of I. Okay, so postfix times answer of I is 6, right? So this just goes to 6. Nice. Postfix has to get updated by doing postfix times nums of I. Okay, so 1 times 4. 4. Okay, moving on. Again, we're going from right to left, right? We're going backwards. So now we do postfix times answer of I. So 4 times 2 should give us 8. Okay, and we have to update postfix, so we do postfix times nums of I. So we do 4 times 3 should give us 4 times 3 should give us 12. Okay. So now we're here, and we do postfix times answer of I to go into answer of I. So 12 times 1 gives us 12. So that there. Update postfix by doing postfix times nums of I. So 2 times 12 give us 24. Right now we're here and we do answer of I is equal to postfix times answer of I. 24 times 1 is 24. Okay, and we would update postfix again by doing postfix times nums of I. So 1 times 24 is 24. But it wouldn't matter, right? Because there's nothing to the left of this that we need to there's no other value here that we need postfix for again, right? So our final answer is 24, 12, 8, and 6. And as you can see, that's what our output should be. Okay, 24, 12, 8, and 6. Okay, so this idea of like, okay, we're here, we need to take everything to the left, everything to the right, and multiply it together. We're basically doing that, except we're handling everything to the left first, right? And then we're going backwards and handling what's a multiplication of everything to the right. And basically answer of I, as we go along, we build out everything to the left and we multiply everything from the right of each index, building out this answer array. Okay, so let's do this. Okay, so we're gonna say create our answer variable, right? And again, everything's gonna be set to 1, and the length of it is just gonna be the length. Now we're gonna handle the prefix stuff, right? So we're gonna say I, right? I want to say answer of I is, remember what we did? We did answer of I times the prefix. And then for the next step, we want to update the prefix. So we're going to do nums of I times the prefix, right? And then we want to do the same thing, but we want to do this backwards. Say reverse the range length of nums, right? But remember, we want to use a postfix here. So now we do answer of I. It's basically the same formula, right? So times postfix, right? Postfix equal to nums of I times postfix, and then we want to return the answer. Okay, and down here it says we can solve this using O of 1 extra space, and we did use O of 1 extra space because the output array does not count as extra space. Okay, so anyways, I know I made this video a tiny bit long, but I just wanted to go through the example basically step by step, just so you actually understand how the algorithm is working. Okay, so anyways, I hope this helped, and I'll see you in the next one. Peace out.